we have our 5.9c complex number plane. Okay, so you have your notes divided. A complex number plane, the point AB represents the complex number A plus BI. To graph a complex number, we locate the real part on the horizontal axis and the imaginary part on the vertical. So instead of XY, we have our real and our imaginary, okay? The absolute value of the complex number is the distance from the origin of the complex plane to the point. So it's a formula. So if it asks you for the absolute value of a complex number, the formula is the square root of a squared plus b squared. Okay, so to plot, we use the coefficient of our real and the coefficient of our imaginary as our coordinates. A is your real, B is your imaginary. All right, so for example here, step 1 is you identify your A and your B. Our A equals -5, our B equals 3. Agreed? Again, our horizontal axis is our real, and our vertical axis is our imaginary. So on the horizontal, it's -5, so I'm going 5 to the left. That's not my stopping point. And then I have 3, so I'm going to go up 3. And here is my -5 plus 3i. The last thing I'll ask you for is the absolute value of the number. The absolute value of the number is its distance back to the origin. That's what you're looking for, is the distance back to the origin. That's the absolute value. Because remember, absolute value is just distance. So the absolute value of -5 plus 3i equals, and the formula tells us we take the square root of -5 squared plus 3 squared. That equals the square root of 25 plus 9. And what is 25 plus 9? 34. Can I simplify that? No, it's 2 and 17, and 2 and 17 are both prime. How do you feel? Easy enough? Yeah? All right. Let's try another one. So here we have what is the graph of the absolute value of the number. So again, our A equals 0 and our B equals 6. So the real, the imaginary, and therefore it's just on the line, on the vertical axis. So when I plot, here is where 6i is. So therefore, the absolute value of 6i is just what? 6. Because you can literally count how far is it from the origin. Questions with just the imaginary? Yeah, so if it asks you to graph, then you would graph it. If it asks for the absolute value, then that's the answer. Okay. Our last, this is example 3. Our real and our imaginary. In this problem, our real is 5, and our imaginary is -1. So I'm going to go 5 to the right. 1, 2, 3, 4, 5. So I go 5 right. And I'm going to go down 1 and plot. And this is where 5 -i is. Then it asks for what's the absolute value of 5 minus I. So how far is it from the origin? So we have 5 squared plus -1 squared, and that gives me 25 plus 1, which equals square root of 26. After doing this, can someone tell me what formula am I essentially using for the absolute value formula? Kind of. Yeah. Uh-huh. Almost. Huh. Quadratic? No. It's very much so the distance formula. It's your distance formula. Yes, it is your distance formula is all you're doing, because absolute value is asking, what is your distance from your starting, your origin? Remember that? That's why absolute value is always positive. All right. So this would be part 2 of your classwork assignment. You have 4 problems. Cool?